As of late, we got a gander at some charming pictures as the James Webb Space Telescope peers back toward the beginning of all that. This telescope has revealed a disclosure that challenges the groundworks of our comprehension, enthralling the interest of space experts and researchers. This disclosure indicates a possibly Goliath occasion prepared to do changing the universe as we presently see it. The importance of this finding is significant, raising worries about the actual premise of our grandiose presence. The inquiry emerges. Might this disclosure at any point lead to the furthest limit of all that we know? Is the universe on the verge of an extraordinary occasion beyond our ongoing grasping? Join us as we dive into the most recent disclosure from the James Webb Space Telescope and explore its chance of reshaping our comprehension of the universe. Our excursion begins with an assessment of the recognizable universe. Our window into the tremendous territory beyond the perceptible universe incorporates all that we would be able to identify, measure, and look at with our telescopes and space missions. It is a collection of stars, worlds, and divine bodies apparent to us, addressing only a negligible part of the whole universe, a little piece of a gigantic, inestimable riddle that people attempt to study and fathom. Notwithstanding our progressions, the general size and structure of the universe remain a mystery. The width of the noticeable universe is assessed to be about 93 billion light-years. This amazing figure results from various elements, including the distance light can go in 1 Earth year. The age of the universe, estimated at 13.8 billion years since the Big Bang, infers that the perceptible universe expands 13.8 billion light-years in each bearing from Earth, prompting a distance across of around 93 billion light-years. Anyway, Hubble's regulation demonstrates that space has been extending since the Big Bang, prompting the perceptible universe additionally extending. Current gauges recommend that items discharging light 13.8 billion years ago from a distance of 13.8 billion light-years are presently roughly 46 billion light-years away. This extension suggests that the noticeable universe broadens more than 46 billion light-years toward each path from Earth. The inestimable development, begun by a strong blast billions of years ago, has not just led to the universe growing but also speeding up. Puzzling powers, for example, puzzling dark energy, seem to be driving this acceleration, stretching the universe's boundaries further apart. As the universe extended, gravitational powers pulled particles together, leading to spectacular structures like stars, galaxies, and planets, including our own Earth. In spite of the immeasurability of the universe, mechanical headways have permitted people to constantly investigate a greater amount of the universe. Particular telescopes, counting the Hubble Space Telescope and the James Webb Space Telescope, have empowered the perception of far-off stars and worlds, making these marvels more accessible to the overall population. In mulling over the astronomical field, it is fascinating to take note of that even within our broad nearby planet group, the universe shows up unusually void. The closest star, whenever downsized to the size of a quarter, would in any case associate with 2 soccer fields far off. This vastness expands just within our Milky Way system, one of billions in the perceptible universe, offering us a brief look into the immensity of grandiose size. As we proceed with our investigation, the new revelation by the James Webb Space Telescope adds a new layer of interest to our comprehension of the universe, provoking further inquiries concerning the idea of our presence and the potential for groundbreaking occasions on an infinite scale. You may be interested in why we can't notice the totality of the universe. There are a few explanations behind this limit. Regardless of light being the quickest object in the universe, it still requires time to go through space. Subsequently, when we notice far-off objects, we are basically looking into the past. The farther an item is, the more its light has ventured out to contact us, making a kind of grandiose time machine that disentangles the historical backdrop of our universe as we witness galaxies millions, if not billions, of light years away. Another pivotal variable at play is the development of the universe. Envision the outer layer of a swelled, inflatable canvas in specks. As the inflatable develops, the spots move apart. Comparably, cosmic systems float away as the texture of space extends. This extension brings about a peculiarity known as redshift, where the light produced by far-off objects undergoes adjustment, and frequencies are extended toward longer, ruddy tones. A few heavenly bodies eventually outperform a critical distance, arriving at the grandiose skyline where their light is excessively far away to contact us due to the continuous development of the universe. Taking into account these two main considerations, the movement season of light and the development of the universe, it's not astounding that we haven't noticed the whole universe yet. Even with the most high-level telescopes and technology, our vision remains compelled by the crucial elements of the universe. We should dive further into these ideas. The size of the universe is a moving estimate in light years. To show the distance light goes in a year, our galaxy, the Milky Way, ranges around 100,000 light years. Even inside our galaxy, the nearest star to our Sun, Proxima Centauri, is roughly 4.24 light years away. When we look into space, we can notice galaxies billions or a large number of light years away, permitting us a brief look into the early history of the universe. The secret of the universe's edge has charmed the interest of people from different fields. While conclusive arrangements remain subtle, three huge hypotheses have arisen. The first suggests that the universe is timeless and tremendous, with no apparent end point, extending always in all directions. The second recommends a limited universe, without an obvious edge, comparable to an enormous round or bended space. In this situation, traveling endlessly toward any path would ultimately bring one back to the starting point, similar to circumnavigating the Earth. The third hypothesis, the multiverse idea, presents the possibility of our universe being one among numerous, each with particular actual principles and ascribes. These universes may work freely or be interconnected, shaping a tremendous and perplexing multiverse. Investigating these hypotheses sparks both logical and philosophical interest. The idea of an unending universe challenges our view of space and its tremendousness. On the other hand, a limited universe without an edge challenges our thoughts of limits and progression, proposing the potential for recurrent examples within the texture of space. The multiverse hypothesis, with its parallel universes, opens up potential outcomes beyond our current understanding, alluding to domains very particular from our own. However, it's crucial to note that these ideas remain hypothetical and tricky, anticipating further examination. Investigating the universe's edge presents significant challenges, making it hard to absolutely approve or excuse existing hypotheses. The boundlessness of grandiose space, combined with the restrictions of our observational instruments and technological innovation, creates obstacles in unwinding the mysteries surrounding the limits of the universe. Anyway, in the midst of this astronomical vulnerability, the James Webb Space Telescope arises as a signal of trust, promising to reveal insight into the baffling starting points of our universe. The James Webb Space Telescope stands apart as a game-changing instrument, offering unmatched exactness in reviewing the universe. This interesting instrument has the potential to reveal the obscure history of our universe, giving insights far beyond our current understanding. As a technical miracle, the JWST has recently made weighty revelations, especially in investigating the universe's edge. One of the amazing discoveries includes the identification of 6 gigantic galaxies going back between 500 million and 700 million years after the Big Bang, published in the journal Nature. This examination challenges laid-out hypotheses about the beginnings and improvement of worlds in the early universe. Shockingly, these old systems show widths considerably more noteworthy than anticipated for their age, challenging forecasts and modifying the account of infinite development. In spite of beginning assumptions for noticing minuscule young galaxies, stargazers were flabbergasted to find these enormous grandiose substances. The development of these antiquated cosmic systems is shocking, tantamount to our 13-billion-year-old Milky Way galaxy. The stars inside these cosmic behemoths possess an immeasurable aggregate mass, with certain cosmic systems possibly having a heavenly mass up to 100 billion times that of our Sun. The JWST's unmatched ability to notice the universe's mysteries is established in its usage of infrared light, undetectable to the human eye. This capacity empowers the telescope to identify faint discharges from old stars and systems, uncovering grandiose leftovers that have persevered for billions of years. Filling in as a time machine, the JWST sends our vision back through the ages, giving important bits of knowledge into the universe as it existed around 13.5 billion years ago. The new revelation of tremendous systems, named universe breakers, has upset our comprehension of inestimable advancement. These surprising discoveries challenge previously held models, scrutinizing the customary conviction that universes began small and advanced steadily over time. The James Webb Space Telescope, with its high-resolution photographs and spectroscopic strategies, has played a crucial role in unwinding the mysteries of these gigantic worlds, surpassing all assumptions. The chance of supergigantic black holes lying beneath these systems adds one more layer of secret to the astronomical texture. In any event, when taking into account just a fourth of the data, the known mass of stars in the universe may now depend on a stunning multiple times more than past gauges. This disclosure prompts a major reassessment of how we might interpret cosmic mass and design, with each new discovery adding to our enormous map and offering a more detailed picture of the universe's set of experiences and advancement. The ramifications of these enormous cosmic systems go past their size, testing central thoughts and inciting a reevaluation of our comprehension of inestimable advancement. The James Webb Space Telescope has played a crucial role in propelling our understanding of the universe to uncommon levels through its state-of-the-art innovation. 1. Astounding revelation by the JWST is the identification of the most established and most far-off galaxies at any point seen. These systems transport us to a period when the universe was only a small portion of its present age, enduring a simple 400 million years after the enormous event known as the Big Bang. What adds to the interest is that the light discharged by these universes left on its journey over 13.4 billion years ago, at last arriving at our detection from the perspective of the JWST. The earliest pictures caught by the JWST repeated the early looks of the Hubble Space Telescope, uncovering various potential systems. Through modern spectroscopic assessments, space experts had the option to affirm 4 of these divine peculiarities, taking into consideration a far-reaching investigation of their physical highlights and exact estimation of their good ways from us. Deciding the distance between systems includes the idea of redshift, as divine objects seem to subside from our perspective due to the extending universe. Their light waves loosen up and shift toward longer frequencies, a peculiarity known as the Doppler effect. While different channels and photos can give assessments of redshift, spectroscopy arises as the lean-toward approach for acquiring exact estimations, zeroing in on 4 universes with red movements more noteworthy than 10. The JWST's discovery grandstands their mind-blowing distance from us. To contextualize this, the Hubble Space Telescope had recently found cosmic systems with red movements of 10.38 and 11.58. Anyway, the JWST uncovered 2 much more far-off worlds with red movements of 13.10 and 12.63. A redshift of 13.2 effectively suggests a time period of 13.5 billion years ago, offering an intriguing view into the universe's previous history. The James Webb Space Telescope's advanced deep extragalactic study, known as JADES, remains as evidence of the telescope's aggressive points. Imagined in 2015 by a gathering of instrument groups, JADES is a worldwide coordinated effort including around 80 stargazers and researchers from 10 various nations. Their goal is to leave on a gigantic investigation of the universe's beginning stages, disentangling secrets that have continued for ages. As we investigate the universe from the perspective of the James Webb Space Telescope, JWST, the ramifications of its discoveries stretch out a long way past simple perceptions. The revelations made by this wonderful instrument not only provide bits of insight into the beginning phases of grandiose advancement, but also prompt major inquiries concerning the nature of reality itself. The presence of these enormous universes from a time so near the Big Bang challenges the broadly acknowledged thought that worlds should develop step by step over billions of years. Rather, the data proposes that circumstances in the early universe might have taken into account fast cosmic system development, perhaps determined by interesting physical cycles that we are simply beginning to comprehend. The JWST's capacity to see in infrared frequencies is especially critical. Numerous divine peculiarities radiate light that has been redshifted due to the extension of the universe, making them undetectable to optical telescopes like Hubble. By identifying this infrared radiation, the JWST uncovers objects that are generally stowed away from our view, counting star-forming locales and early-stage universes. This capacity opens a new wilderness in cosmology, empowering researchers to accumulate a riches of data about the universe's first phases, including the development of the first stars and the development of complex structures. Besides, the JWST's perceptions challenge our comprehension of dark matter, a substance that is accepted to make up a critical part of the universe's mass but remains slippery and hard to recognize. The presence of huge cosmic systems so right off the bat in grandiose history brings up issues about how dark matter contributed to their development. It suggests that dark matter might have played a more dynamic role in shaping the early universe than recently suspected, impacting the gravitational dynamics that prompted cosmic system arrangement. Notwithstanding reshaping how we might interpret cosmic system development, the JWST's discoveries offer tempting clues about the circumstances for life beyond Earth. The presence of components like carbon, oxygen, and nitrogen in these antiquated worlds could suggest that the building blocks of life have existed any longer than we once expected.